So first part of 8.2, we went over the we went over the compound interest and continuously compound interest formulas. So we know two more exponential functions. This last half is I'll talk about the number e, the natural base e. Okay? Also known as the natural base e or the Euler number. Okay? Now, if you're asking what is that value, we know pi is another one of those special values. We know that's 3.14, and it keeps going on, but 3.14 is a solid number. You can find this if you have your calculator ready. E to the 1 power should give you 2.718. Okay? So that's going to be pretty close to the value that we're going to get. The formula to get E, 1 plus 1 over n to the n power. Now that should look kind of familiar. It does resemble the compound interest a little bit. If you would plug this into your calculator under y1 and go to your table, the bigger and bigger n gets, that's going to be closer and closer you're going to get to 2.718. So you can go ahead, plug that into y1, go to your table and start scrolling down. It might take a little bit to get close to that value, but eventually, as n gets bigger and bigger, you will get closer and closer to 2.718. So that's why they switched the compound interest formula to the continuously compounded interest. If you start compounding by seconds, by half a second, then you're going to be getting closer and closer to a big enough value to just get it to 2.718. And that's why when we do this, when you do that formula continuously, it's happening all the time. So it's going to be such a large number that you don't use the compound interest formula anymore. Okay. Right here. Now, is the function going to be growth or decay? Before, in the first section, 8.1, we looked inside the parentheses. And if that inside those parentheses was greater than 1, we knew it was growth. If it was less than 1, we knew it was decay. Well, e is a set value. So instead of looking at that value, which e is basically the value inside the parentheses, we have to look at the exponent. Okay? There is no set of parentheses here. That's set at the value of e. So we're going to look at the exponent. If the exponent is positive, it's considered growth. If the exponent is negative, it's considered decay. So looking at the function, see if there's an e for the b value, and if there is, you have to go to the exponent. When it comes to simplifying values with e involved, this is just like any other exponent, or sorry, any other variable. Do the exponent properties. Division is subtraction. Okay? When you're multiplying, you add the exponents. 5 times 3 is 15, e to the 8th. And when you have exponents inside and outside, you bring everything to that power and multiply the exponents. So we should have 625 e to the 12th. Okay? So that's basic simplifying with like any other variable. Okay? So that's the end of 8.2.